Okay, guys, I think we can start. Do you hear me all right? Good. Okay, good morning, everyone. I hope you're having a great day, the first day of this incredible conference in Porto. And I'm excited to be here today to be speaking about React Server Components. So this talk's topic is React Server Components. First, why should you care about them? Obviously, React and JavaScript is ever relevant, and with RSC, we have a completely new way to build React apps. So React Server Components allow us to fade the boundary between the server and the client, to create rich user interfaces with minimal client-side code while still maintaining interactivity and performance. So my goal today is to introduce and motivate and provide resources about RSC. As a non-frontend developer, you will be able to get an understanding of what's happening on the front-end side of things. And as a front-end developer, you will get the tools needed to start building apps with RSC and consider them for your next project. Before I start, let me introduce myself. My name is Aurora Walberg. I'm from Norway, and I work as a consultant at Meta in Oslo. I'm a full-stack developer, but I work mostly on web these days, and I'm actively building with RSC in my current consultancy project. And I bring to you today my view as a developer joining the cutting-edge web world and how I'm learning and working with modern technology. So the talking points of today will be first, rendering strategies. Then we'll get to React Server Components, what they are, how they work, and what are the benefits and the drawbacks. And then we'll go through Next.js 13 and the app router, then on to best practices and patterns when using RSC in Next.js. And then afterwards, I'll show you some examples of RSC in a demo app that I've made. And finally, give my thoughts on working with RSC in a real project, as well as the future of React Server Components. Let's begin with rendering strategies. You can't have a talk about web development without mentioning them. It's a crucial prerequisite. And I won't mention every type of rendering strategy and the history of the web here, but I will pick and explain some relevant topics. And this stuff will probably be familiar to a lot of you. So first, static website rendering. It's the most basic rendering pattern where all web pages are assembled beforehand and uploaded as static files to a storage bucket. And it can be built with plain HTML or combined with CSS and JavaScript. And it's delivered exactly the way it's stored, meaning nothing will change unless the code is changed. And although quite simple and efficient, it doesn't handle dynamic data or interactive websites well, and it's impractical to maintain. A use case for this could be an informational website for a business. Multi-page applications, on the other hand, can handle dynamic data. In an MPA, HTML and data is merged on the server per request, and the user will open a browser and be served the merged result. And the entire page will reload per request or navigation to a new page. They can be created with, for example, the ASP.NET MVC pattern, or with PHP or Ruby on Rails. Use case would typically be an e-commerce app. For example, Amazon is an MPA. So what are the pros of MPAs? Firstly, all the page content can be read and indexed by search engines because it's rendered HTML, allowing them to appear in search results and be optimized for it. Then, there's no restriction on the number of pages that you can add. Performance will be the same, meaning they have unlimited scalability. And last, they can provide more website insights. For example, Google Analytics can create reports for each page. And the cons? They have slower overall performance because they reload on every navigation. And they also require more effort to create features. And they can be harder to maintain because each page needs to be maintained separately. Then we have the single page application, or SPA. The SPA will typically be a React app of Create React App, or Vite, or an Angular app, Vue.js app, etc. It's been the most common way to build an application for many years. And in a SPA, the bundle.js file includes everything you need to build the app. And the entire HTML is created on the client when a user opens the browser on the app's URL. And the page will be blank until the JavaScript is downloaded, parsed, and executed. And then React starts building inside the root div and finally loads the data. And after it's loaded, only data in JSON format is needed to update the UI. The use case for a single-page application can be any web app that needs to be highly interactive. So what are the pros of SPAs? First, they're fast, there's no lag, they've got smooth transitions and instant information present after the initial load. Second, they're easy to debug because everything can be logged in the browser because it's browser only, such as data, page elements, and network operations. Third, they use less bandwidth because pages are only loaded once. And fourth, since everything is downloaded initially, they can work offline afterwards, cache data, and then update when possible. But there are some significant cons. Most importantly, they have a slow initial load, which is increased with everything that is built on top, such as libraries. And meanwhile, the user is just looking at a blank screen and then afterwards a bunch of loading spinners. Next, search engines like Google cannot know what's on the page because crawlers read strings, like HTML, and so typically a SPA won't show up in the search results unless they're optimized in certain ways. They also need JavaScript to function, and therefore they cannot be progressively enhanced. And furthermore, they require tools existent in modern browsers, and they use a lot of resources. And finally, they cannot hide information from the client because the data only exists there, meaning things such as API keys cannot be stored in a SPA. For that, they need a backend or a serverless function. So the key difference between an SPA and an MPA, in an SPA, everything loads initially, and then only data in JSON format is required for making updates, whereas in an MPA, the entire page reloads per request. This brings us to SSR, which combines the advantages of MPA and an SPA. So instead of generating the entire application on the client from the JavaScript bundle, server-side rendering means that you can pre-render the initial pages on the server and then send them on demand. So this lets the user go to a URL and instantly see a fully formed page with components. And then the JavaScript required to interact with the page is sent alongside the HTML. In relation to SSR, we also have something called static site generation, or SSG, which lets us pre-render pages in the build process of the app and upload them to a storage bucket. The result of SSG is the same as with quick and simple static website rendering, but we can generate the pages from, for example, React code. A problem with SSG is that the build time scales linearly with the number of pages, meaning if you have a lot of pages, you could be waiting a long time for your app to build. And also, you have to rebuild and redeploy your site whenever data changes. Server-side rendering is implemented in so-called meta frameworks, which are frameworks around other JavaScript frameworks, such as Remix and Next for React, SvelteKit for Svelte, Next for Vue. And these frameworks are full-stack implementations of a web app, meaning they have their own server with things happening on. And they support both SSR and SSG and can decide when to use what. For example, an app has a couple of pages, which one has data that is changing. In the build process, all the static pages are rendered, and when the user opens the app, only the page that has dynamic data will be rendered at request time. And these meta frameworks typically also include things that, like file-based routing, APIs to handle data fetching on the server, caching capabilities, and image optimization features. Let's get back to that JavaScript that is sent along with the pre-rendered pages in SSR. We still need JavaScript to run on the client to handle any interactivity. So instead of conjuring all the DOM nodes from scratch, the framework, like React, will adopt the existing HTML. And this process is known as hydration. The framework will attach the event handlers and, for example, fire effects and add state, and afterwards the page is fully interactive. However, it essentially has to rebuild the entire tree and compare it with the existing one to know what to hydrate. This quote by React core team member Dan Abramov explains it well. Hydration is like watering the dry HTML with the water of interactivity and event handlers. So there you have SSR in a nutshell, done by modern frameworks like Next.js. It lets you load the initial page quickly, yet still have an interactive SPA. Now this sounds great, however, SSR isn't perfect. First, after the initial fetch of the HTML, can the browser download the JS code, parse it, and then execute it? And this causes the pre-rendered HTML to look interactive, but in fact, it doesn't contain any JavaScript yet. So the user is stuck in a place often referred as uncanny valley, where they will click a button, but nothing happens. And the time until they can interact with the app might even be longer for a plain SPA version of the app. Why does this happen? First, you have to fetch everything before you can load anything. All the HTML with the data fetched must be processed on the server before it can be sent to the client. Secondly, you have to load everything before you can hydrate anything. That's because React needs to match the tree in the browser with the one from the server. Third, you have to hydrate everything before you can interact with everything. React starts the hydration, and then it doesn't stop until it's done. There are many techniques being utilized in different frameworks to solve the hydration problem. Partial hydration can be used to define that only certain components need to have JS attached to them. For example, in Astro, you can define components to hydrate with the directive client load, and you will also see this in React Server Components later. With progressive hydration, you can lazily load components JavaScript, for example, with Astro's client visible, or with suspense in React 18. Selective hydration lets you prioritize which component to make interactive first based on user interaction. And this can also be done with suspense. And there are a bunch of ways being implemented in other frameworks, such as with resumability and quick. Let's also mention the concept of streaming. It's a part of the fetch API of ES6, and it's available in React 18, and it's a big part of React Server Components performance. Streaming allows you to break down a request into smaller chunks and progressively send those chunks from the server to the client, then render each chunk as it's streamed in. We can use it to send components down to the client as soon as they've been generated. Finally, with all this knowledge, we can move to React Server Components and how they solve the problems we saw earlier. What if we could decide when we needed the behavior of a SPA, or an MPA, or SSR, all in the same stack? I'm going to be using some simplified examples of code from my demo app in this section here. So what are they? React Server Components are components that run exclusively on the server and are then streamed to the client. Server components never re-render. They run once on the server to generate the UI, and their JavaScript is never sent to the client. And when I say render on the server, I mean the server that is part of the full stack framework, such as Next.js, or during the build process of the app, not some .NET backend API. This is the frontend's own backend, which in many cases eliminate the need for writing a .NET API. Server components differ from server-side rendering because they are never hydrated, meaning the resulting app is partially hydrated. Hydration to non-RSC components can happen concurrently with RSC streaming in, since the compute load is shared between the client and the server. And since RSCs are run exclusively on the server, we can write database queries right inside our components. Here's an example of a simple server component called JokesList. I can query my database through an ORM like Prisma and have the data available and fully rendered before it's sent to the client. Server components introduce async components, basically an async function, that can asynchronously fetch data on the server without causing any issues for the client side. And you can do any kind of data fetching in here, such as calling your API. Because React Server Components only render on the server, this means that a big chunk of React's API is incompatible with them. For example, we can't use state because state can change, but server components can't re-render. And we can't use effects because effects only run after the render and on the client, and the server components never make it to the client. We also can't use any browser-specific APIs, such as window.location, because they don't exist on the server, and we can't use onClick and onChange because they require JavaScript. Server components themselves are simple, but the React Server Component world is more complex, because we still want to have interactive components that include state and effects and event handlers. So because of this distinction, there are now two types of React components: server components and client components. Client components are the normal React components that you can do whatever you want, you're used to inside. Note that they are still pre-rendered during the build and then hydrated on the client, as with pre-existing SSR. However, client components must be marked with use client. This allows us to use things like state and effects and onClick as normal. Here's an explanation from the Next.js app router docs on the limitations in server and client components. If you need to fetch data, access backend resources, keep sensitive information on the server, or keep large dependencies on the server, use a server component. And then if you need to add interactivity like on-click, on-change, or state, or effects, or browser-only APIs, use a client component. How do they work? What happens is that React server components are rendered into a special format called the RC payload. It's a streamable format that represents the DOM, and it's like a serialized version of a React tree. The RC payload contains the rendered server components with holes of references to client components and the props they pass down to them. It's used both to generate the pre-rendered HTML on the server and to update the DOM on the client without a need for JavaScript. Here's what it looks like in the console. We have the server-side rendered jokes HTML as well as the RC payload and multiple client-side JS bundles. They are used together to create the interactive page. Since the jokes list component is defined as server only, it doesn't need to be hydrated at all, and its JavaScript isn't shipped. As with everything, it's quite complex when you start digging, so let's leave it at that for now. When an RC needs to be re-rendered due to data change, it refreshes on the server and then seamlessly merges into the existing DOM without a hard refresh, updating only the parts that have changed. As a result, the client state is preserved even as parts of the view is updated from the server. And this is possible because the RC payload only contains references to client components and can leave them untouched. What are the benefits of using React server components? Firstly, data fetching. Data fetching can happen before they are sent to the client and will be faster since RCs can call the API database in proximity to the resource, as we saw in the jokes list example with Prisma. And inside RC, you have access to all your backend resources. Next, they can increase security by keeping sensitive data and logic like API keys on the server and never risk exposing them. Then, caching. By rendering on the server, the result can be cached and reused on subsequent requests and across users. And bundle size. Server components allow you to keep large dependencies on the server, meaning you can exclude all that JS for those components from the bundle without restricting your use of them. For example, a library like Lodash, which leads to a more performant application. Server components can furthermore be streamed, meaning they can be sent in chunks and then viewed as they become ready. Therefore, they integrate naturally with React 18 suspense. Finally, developer experience. There's a lot less hassle on the client side with effects and keeping data on the state. Just fetch it async off the client. RC, however, comes with some drawbacks. Firstly, they need a framework. In practice, you will only be using them in frameworks like Next.js, which is per now the only reasonable way to use them. They also create increased complexity. As a web developer, you now need to understand a lot more concepts, such as what you can and can't do on the server, which you didn't have to think about when you were just making a spa with Create React App. Next, it can be hard to onboard new developers because the learning curve is a lot steeper when aiming to write quality apps. And finally, it's still relatively new, and not everything has been figured out, such as testing and compatibility with other frameworks, libraries, which I will get back to. And you risk having to refactor things or write specific workarounds. For example, Material UI just recently became compatible. How can you get started with RC? As mentioned, the only reasonable way right now is with the Next.js 13 app router. So Next.js is made by Vercel and is battle-tested and enterprise-ready. And React Server components are part of React 18, but they've been developed closely with Vercel and Next 13, which is good for building apps with them because everything is optimized and working smoothly, and as well as having the entire React ecosystem follow. To make a Next.js 13 app, run this npx create command and define whether you want TypeScript and Tailwind and such. And you will need the app router option set to yes to use RC. That will generate the boilerplate for you, and you can start using RC. There's not a lot of files to confuse you. It's mostly standard files such as package.json and tsconfig, and some config for Tailwind and ESLint. What matters is everything inside the app directory. So in the app router, you will be coding server first, meaning everything you do is a server component unless specified otherwise. which means that the layout and the page files are server components by default. I won't spend too much time on the pages router today, but basically you don't have to use functions like get server-side props anymore, as the pages are server-side by default, and you can fetch data just by calling, for example, your API inside the component. It's a lot more straightforward. There are also a lot of changes to the file-based routing compared to the pages router, but I will just explain the new app router way now. In the app router, you define routes by making folders containing a page.tsx. That makes it a valid route. I have some routes here, /jokes, and then a /new and joke ID subroute, which is a dynamic route, meaning it's parameterized. Then you can also use files with reserved names such as notfound.tsx and error.tsx, which are error boundaries that render inside the layout of their route, as well as loading.tsx, which creates a suspense boundary around the page. All of these can be granularized, by the way. You can add them to the root, or to subroutes, or to anywhere you want. And there are also a lot more features like ignoring folders from routes with underscore or grouping them with parentheses. You can also define API routes in here, like in the pages router. The route.ts file is a reserved name and will allow you to create API endpoints. Then there is support for SEO with, for example, meta tags. They can be added to any page or layout and can also be generated dynamically, for example, using the route params. With Next.js comes a lot of optimizations, such as caching. All pages generated in the build are cached on Vercel's CDN if you host it there. And Next.js will also optimize your images if you use the image tag, and will do things like preload your pages on hover if you use their link component. So how do we use React Server Components in Next.js the right way? What are the best practices and development patterns to get the most out of them? The best practice is going to be to move your client code to the leaves of the component tree. In this way, you ensure that you do not ship any unnecessary JavaScript to the client. React will hydrate only these client leaves, as we know as partial hydration. You could, in theory, just put use client on your root and code however you want, but that just means that all your components will have their JShip, and which just takes us back to standard server-side rendering. To use a client component in a server component, you simply import it. Here's the delete functionality has been extracted to a component, the delete joke button, with use client because it needs an on-click event handler. However, when going the other way around, you cannot do the same without turning the server component into a client component. You instead need to slot them as props, and they will fit as separate chunks into the client tree. The client component does not know what is being passed down, and this can be referred to as the donut pattern. This means that our tree can look like anything we want. We can add client-side logic in the parent components as well. Only the green components are hydrated and contain JavaScript here. The rest is just HTML. With this pattern, we can furthermore implement things like state management. By providing a wrapper client component with state, for example, using React Context, which only works client-side, we can use the state in the leaves without converting the server components in between. For example, we can make an error message provider or a theme provider. When combined, this allows us to make apps that are extremely performant due to their large amount of static content while still being fully interactive. You could have a donut pattern, collapsible sidebar, a theme toggle provider, a search and buttons and on the client side, and then the rest can be static. And you can share your state between components however you need. When building an RSC component tree, there will be some limitations between client and server components. For example, since the client exists on the client, the client components exist on the client and the server components on the server, props need to be serializable. This means that we cannot pass functions through the server boundary. Instead, we must create API endpoints to communicate between them when we can't use props. Or Next.js 13 server actions, which will simplify the process, and I'll explain that later. how do we manage data with RC and the app router? I already showed you that you can make database queries through an ORM like Prisma, and you can, of course, use the fetch API, and there are a bunch of parameters you can add here, such as cache duration, tag for revalidating the data, headers, and more. So here's an example of showing what you could potentially do. For example, getting a cookie and making an authenticated request to an API. And getting data this way into your server components is very efficient because on the server you have this privileged environment with everything you need accessible. If you use the same data in multiple components in a tree, you do not have to fetch it globally and pass it down. You can fetch it in each component where it's required because it's automatically memoized. You can compare this pattern to, for example, React Query, where you will call your hooks wherever they are needed, and then they will all call the same cache data. Plus, you can pass it down to client components when you need it, for example, as the options of an autocomplete component. What about data mutation? I mentioned that you can create API endpoints like in the Pages router, but let's skip that for now and look at something way better called server actions. They're not stable yet, they're moving towards stability, but they're going to be the preferred way to mutate data when they're stable. So I want to show you what they are. It's simple. You mark a function or a file with useServer, and Next.js will make a hidden API endpoint for you, allowing you to call it from anywhere, like from a client component, solving the problem of passing functions between the server and the client. In addition, this gives you type safety between the server and the client through RPC or remote procedure call. Here I have a file with a function marked with useServer, turning it into a server action. I can now call it from a client component, and that's it. However, I also need to tell Next.js that I have changed something inside the data in RCs, that it needs to revalidate the view and fetch new data from the database. So I then call revalidate path with my relevant route. Server action also works seamlessly with form submissions. So here I have a form and a function marked with useServer. Note that it's inside the component here. And with submitting the form, it can, without JavaScript, call the server action and add a joke to the database. And again, I need to tell Next.js that I changed something, and it has to revalidate the view. That's just some quick examples. There's so many possibilities here, and it's extremely efficient to develop with. So there you have it. React Server components in the app router allow you to do whatever you need to do, whether it's MPA functionality or interactive SPA stuff, and include SSR or SEO or any kind of functionality you need, all in the same stack. Optimized. Amazing. So hopefully you remember some of these terms by now. It's a lot. React Server components bring a new mental model and architecture. So, oh yeah, and there's a lot more to say about RC that I haven't included here. Let's get into a demo of the joke app. It's a remake of a tutorial from the remix documentation, but of course very different because it uses RC and Tailwind and server actions. It's also containing very simple implementations to not clog the code with complexity. So this is the app. It has some basic, oh, sorry, it's not mirrored anymore. Good thing you're telling me. Is this okay? Good. So it's a simple app to display a list of jokes and add jokes and delete jokes. So you can view jokes here, and then you can add your own. For example, why was the developer unhappy with their job? That they wanted a raise. So then it's added. And then you can also delete them. That's the main functionality of the app here. Let's look at the code for this. Oh, sorry, I forgot to mention. This is deployed on Vercel, and it uses Tailwind and Prisma and an Azure SQL database for the database through Prisma. So this is the files that you maybe recognize from the boilerplate. Inside here you have, well, you first have some basic stuff like ESLint and Prettier, and then you have the source folder with the app router folder, which is the most important one here. Then there's some validations for the forms, and some database utils and components, and server actions in here. And inside the app router, we have the root layout. Is this okay? Yes? Yes, okay. Which is not important, and then the root page, which is this page here. So this is just some Next.js links, not interesting. Then there is the jokes route. And in here we have the root layout, which is containing a header, a footer, and a sidebar. And in the header, we have some links, well, just actually one link with the logo. And the footer, also some links. And the sidebar is containing the jokes. So in here, we have a random joke button, and the jokes list, and a nav button to add your own. So let's look at the jokes list first. This is using the database call like this, Prisma joke find many, and then just sorts them and maps them into links. And then there's a nav button. It's just a button that routes you to this new page. And the random joke button, which is just refreshing the page. Then we have the new joke page, which is here. In here, there's a form, and this is actually a server action, create joke, and which is bound to the action prop, which is the way you can use them without JavaScript. And there's a submit button here. So inside create joke, this is a server action because it has use server. There's just some very simple validating of the content, and then Prisma adding it to the database and revalidating the path. So when I add something here, it's going to call the server action and then add it to the database and revalidate the path and redirect me to the new joke that has been created. This submit button could have been just a basic button, but I've added some visual feedback here that it's submitting using this hook called use form status, which is just giving me the state of the form that it's used inside and displays adding if it's pending. Let's also look at the joke ID, which is what's being displayed here. In here, I have an error.tsx, which is going to be triggered when something goes wrong, and a not found, which is going to be called when the joke is invalid. So it's an error boundary. It's going to be rendered inside the route that it's in. And in the page, I'm getting a joke here from Prisma with the param joke ID, which is up here. And then if the joke isn't, if it didn't find anything, it throws not found. And then there is a link to the joke and the delete joke button, which is passing in the ID of the joke. So this delete joke button is also using a server action, delete joke, which just deletes the joke and revalidates the path and redirects back. And this is actually a React 18 feature called start transition or use transition. And there's a lot of these React 18 features inside the app router that you don't think about that is being used by Next.js, but you can also use them explicitly, like here. It basically will mark a state update, in this case delete joke, as non-blocking, allowing you to cancel the action by clicking around the page. And it also gives you the pending. So I'm using the pending status here to display delete when I delete it, or deleting when I delete it. That's all for this app here. But I have added a bunch of other routes to display concepts in RC. So I'm going to go through those also quickly. And I want to show you, well, not yet, actually. Oh, yeah, here. Is this OK? OK. So first, nesting. So as I mentioned, you can put server components inside client components if you slot them like this. So the server component is rendered on the server, and the client component doesn't need to know what's happening. It just gets some content here, which is also rendered on the server. And the client component is interactive, and this is rendered on the server. Then revalidate. So as I mentioned, you can update the state or the server components from the server, and then keep the client state. And that looks like this. This is not very important, actually. The point is that I'm adding some state, and then adding, oh yeah, this is fine. And it will then update and refresh the view without changing the client state here. It's still just maintaining the state, even though this part is server-side. Then I mentioned that you can make providers, which is how you're going to be sharing your state. So let's say you have a server component containing a client component and a client component over here. So they're in different parts of the tree, so they can't really communicate. But you can make this theme provider with React context, and then set the theme from a client component with the context, and then use the theme from a context. And you could be adding this theme provider to the root of your app so that you can use this anywhere. And it will just be shared like a normal global state. Then there's a bunch of different ways you can make forms. So I have here a server form, and it's using a server action. And inside this server action, I'm using Zod to safe parse validate the data, which has to be this long, contain this many characters. And if it doesn't validate, it will return a server error. So what happens is I add this. Did something happen there? Let's try that. Oh yeah, that's because I'm not on the local. That's why. Yeah, let's get back to this. So as you can see, it's now failing on the server side. Then we can also client-side validate. So this is also using a server action, but here it's parsing the joke in the beginning. So what happens here is if it fails, it's going to give me the validation message here, because this is on the client. And you can combine this to make, for example, a React hook form using optimistic update, and then have both client-side and server-side validation. So here I have a form. It's giving me error messages using React hook form. You can also open this. Yes. And it will optimistically add a joke. So it's going to be quick, and then it's going to optimistically add it, and then check later if it was added. So I have just added some validation on the server here that's going to be stricter. So when it's failing, it adds, and then it removes it again. So you can make really smooth interfaces here by using, for example, React hook form and server actions combined. I also have an example of using React query. You probably won't need to because you want to be fetching data only on the server, but it's possible. So check that out if you want to see how it's done. And then finally, I don't know how much you know about suspense, but basically it lets you stream content as it becomes ready. So here, and this is also a React 18 feature that Next.js uses as a part of their built-in functionality that you can use explicitly. Suspense. So first of all, I don't know if you saw this, but it was displaying loading page. This is the Next.js suspense boundary loading.tsx. So this is creating a suspense boundary telling React that you want to see this content while something else is loading. And then inside the page, I have some more suspenses. So here, the jokes, well, first of all, there's a timeout on this page of 1 second. Then inside this jokes header, 2 seconds, and this jokes call has 4 seconds. So basically, I want to display data while other data is loading. So I can add suspenses and add different fallbacks, letting me stream the data that takes longer while I'm displaying the data that is done. Let's just look at that again. So it's loading this part, doesn't know this yet, and then it's finally loading this last long call from the server. This is very useful when you want to display something while something else is loading. And what happens is this counter, if this is important for the user, I can click it even though the data is still loading. I think that's it for the demo. So let's get back to the presentation here. Oh, hold on. Yes. So this is the lighthouse score of my app. It's unoptimized. I just followed the patterns mentioned. And of course, this is a very small app, but you get the point. And all in all, you can build very performant apps by default, and the limitations of RC kind of make your code better, unlike in React, where you can do wherever you want. Here's also the badge for the app when sharing a link to a joke. So you can see the dynamic metadata is creating a badge. So I have real-world experience with RC because I'm using it in my current consultancy project, building a medium-scale production app. So let me just mention my requirements and my experience with that. I'm working on a project set to last 1 year. It's a rewrite of an existing MVC app that has a lot of technical debt. And I've been lucky enough to be given the responsibility to pick the technology for the front end of this new solution. The app will contain interactive dashboards, complex forms, articles through a CMS, and a lot of static data, and a need for SEO. It also needs to be mobile-friendly and support multiple languages and use custom authentication. So a big part of this app, and something that I made sure to proof of concept with RC before choosing framework, is the customer's design system component library. This app is a great case for RC because it can server-side render a lot of content, but also be highly interactive where it needs to be. I'm finding it to work very well so far. However, I've had to do quite a bit of trial and error to build functionality that is non-standard. For example, I've had to create wrapper components for the customer-specific component library to be able to use them in my project and put server components inside them. I've also had to pick my my internationalization library without much guidance from Next.js. It's working well, but there are certainly complexities. And finally, testing RC is not covered properly anywhere, and to test async components with React testing library, you have to use a workaround, as for now. But all in all, it's going well. There was a learning curve, but I'm enjoying it every day. My app is performant, it fulfills the requirement, it's maintainable, it enforces best practices, and the developer experience is great. The Next.js app router with RC provides so many tools to let me focus on building my app. To finish this off, what is going to be the future of RC? There's no doubt that this is the way React is going now. It's not just some hype cycle that is going to die out. It's the result of many years of work of the React team. And it's likely that other frameworks will implement their own versions of these RC or implement RC, such as with Remix, who recently announced that they will. And there are so many solutions being proposed to improve the performance of web apps with the goal of finding the optimal balance between UX and DX. And this is React's take. Nonetheless, there's still a lot of things yet to be figured out as React Server components are being battle tested. Here's the repo for my joke app. You can use it how you want. Everything is there, as well as the reference demo pages. Here's also some more resources that I've been using during my learning experience and when making this talk. Vercel has a bunch of template apps to reference, for example, examples of integrations with different libraries. And the Vercel docs is amazing. You can find anything there. Just make sure to select the app router version of the docs when you're on the page. Also, ByteGrad on YouTube has high-quality RSC stuff, and he's launching a full course next month. And Code with Antonio has a lot of public projects on GitHub, as well as full YouTube walkthroughs. For example, making a Notion clone, like 7 hours making a Notion clone. It's really good. And of course, I have a lot of code that I can't share directly from my current customer project, but you can reach out and I will send you examples or explain how I've done things. Thanks for listening. I hope you're as excited as I am. As excited as I am and ready to try it. And this is my social media. I'm trying to get there. And I'm going to post my slides on Twitter, and you can contact me there. And I have a blog. I have some resources about testing RSC there. Thank you. Do you have any questions? Yes.
Yes. I find interesting the primarity of the cache control.
Yeah.
For instance, if you have a component, let's say a navigation thing, that's included on all the pages, and then you have different pages that only changes when it's on pages. Can you control that?
You can. The thing is with caching, sorry, I can repeat the question first. Can you control the caching behavior? For example, if you have a part that is not changing and then some parts that is changing, can you control the way this cache works? That's correct? So it's specific to deploying on Vercel that everything is cached, but they have these, like, basically you write on the top of the file, like export const, and then define what type of caching behavior you want for a route. So you can say, okay, this route is dynamic, then you put this const on top, it's going to keep this one always rendered on the server, and then the rest is just cached by default. So there are these specific kind of consts that you can put to control the caching.
So it's still URL-based?
Sorry?
So it's still URL-based?
URL-based. Not really, because this RSC payload is kind of in chunks. Well, it's file-based, I guess. You can say it's file-based because, for example, in this my jokes list, I'm defining dynamic cache, but that's not a component. That's just that's not a route. That's a component. But I can. Yes, at the back.
Got a mic. Hi. So I'm going to take advantage of the fact that you've built like a clone of the Remix Jokes app to ask your opinion in terms of difference of using the Remix's loader compared to, well, RSCs.
Yeah. Okay, so the question was, what's my experience using the Remix loaders compared to RSC?
Yeah.
So in Remix, you have these loaders. It's kind of like getting data in a server component. And I only made this, I only used Remix in this Remix tutorial app. But my initial thoughts is that you can get it very structured when you can put your data fetching, for example, in its own actions folder. You don't have to link it to a route. You can use it wherever you need, like just put them in the actions folder, then pick them. So it feels more organized, maybe. Yeah. Less code in each file. You just call somewhere else.
Thank you.
Anything else? Okay, thank you. Thank you.